Good morning, class. Today we're going to review some problems from your midterm.
Oh my god, I hate midterms. They're so pointless.
Alright, now what are some topics that we've already covered this year in physics?
We've learned forces, work, measurements, projectiles, energies, and types of motion.
We learned some of those.
Good. Now, what topics are important for this particular problem?
Projectiles and energy.
Specifically, the conservation of energy.
Very good. Now, if I were you, I would recommend breaking this problem into two parts. One for the projectiles and one for the conservation of energy. Does anyone want to walk me through their work for that part of the problem?
Well, first we have to
Wait.
let me draw it.
Will you please come draw your picture for us?
Sure thing.
Good job, thank you. Please return to your seat. Now, Rachel, could you please explain how to do the conservation of energy portion of this problem?
Well, first we have to acknowledge that there's not any friction acting on the pendulum, and so from the mechanical energy equation, which is mechanical energy initial equals mechanical energy final, we can substitute variables to find a value, and so we can say that kinetic energy initial plus potential energy gravitational initial plus potential energy elastic initial equals kinetic energy final plus potential energy gravitational final plus potential energy elastic final.
So there's no elastic energy in this formula, so we can cross those off on each side. So we're really only solving for potential energy initial and kinetic energy final. The equations for those, we have mgh on the left side is equal to 1/2 mass times velocity squared. Mass on both sides, that can cancel out. We know g, which is 9.81, and we have to multiply by the height, which was 0.7192 meters. The left side is 7.05. Set that equal and divide by 1/2, which is 14.11, and take the square root, so these should equal 3.756.
Nice job. Now, with this part figured out, we can move on to the second part, the projectile. Who wants to talk me through that?
So we need to set up two columns, one for the vertical and one for the horizontal movement. Each column should have 5 variables: distance, final and initial velocity, time, and acceleration. On the vertical side, we know that gravity causes an acceleration of 9.81 meters per second, and the distance measured was 1.034 meters. We also know that the initial velocity will be 0 in this because for projectile motion, the first movement is horizontal. And with that, I guess we can use the kinematic equation: final velocity squared equals initial velocity squared plus 2 times the acceleration times delta y. And then we get 4.5 for the final velocity. Then using another equation, final velocity equals initial velocity times acceleration and time, we can determine the time to be 0.4587 seconds.
Yes, that's it!
Yeah! Woo!
So now we can fill in the horizontal portion. So we know that acceleration is 0, and then the time we found is 0.459 seconds. And since the horizontal and vertical motion is the same in projectiles because it's happening simultaneous, then the time's the same on both sides. And then from the conservation of energy equation, we found that the initial velocity was 3.756 meters per second. And so now we have enough information to use the kinematic equation, which is velocity final equals velocity initial plus acceleration times time. And then that's in order to find the velocity initial, which is also 3.756 meters per second. And now we can find delta x, which by using the equation, delta x equals 1/2 times velocity final plus velocity initial times time. And then when we do that, we get
1.724 meters.
Great job, class. Now let's set it up and see if we can get the marble to fall in the cup.